Morning everyone, hope you hear me now. Let's just double check one thing. Okay, it should be in every single output. Yes, perfect that you hear me. Let's start opening up the development environment. So I have some special stuff from Twitch because of success of yesterday's stream. So I can now give you guys some good status for everyone who chats. So let me just add some statuses. Elegantis, Agalanis, enjoy your new status in chat. Now, merge on. Now I'm gonna do as well the same for you. Let me try again. Oh, perfect. Interesting. I cannot add the status here. Oh, looks like you have as well the status. Oh, nice. A new notification came in. Damn. So many stuff to click on. Just trying to copy over your usernames. So, how was everyone's day today? In Netherlands, also very rainy at the moment. Oh, SQL exception. But are your kids like on vacation? Okay, this stuff I think done. – 24/7 time for coding. Okay, nice. You also need to find some time for other stuff too, not only coding. Okay, let's put notifications out. Okay, let's put the link there. Okay, let's put this stuff here. Okay. Okay, perfect. Done. Now we can go switch to other view in OBS. So you remember where we stopped yesterday? So what we have here is we did have some code that basically was duplicated within adding a row and within finishing. So I just moved it over with a small refactor off stream yesterday. It's the only change I did. So let's go with continuing. Hey, Process 8. Nice to see. Nice to see you here. Thanks for signing up for Twitch. Now because you just signed up for Twitch for that, you have now special chat status too. So enjoy it. Okay, so what I wanted to do yesterday, what I did want to continue, I wanted to use this entity data in some way. So we probably like want to supply this entity data together with entity ID itself in order to let some data being generated and then sent to the index writer. So let's see. Probably we create another interface, and I'm gonna call it indexer. Actually, index generator. So it's just gonna generate an index record by taking a writer as an argument and also the event data itself. It's going to be actually the final implementation of the indexer itself, and I will need it for some testing. It itself. So let's see. So we go with index generator, and now we're gonna create a method here, and the method name is gonna be generate probably, or maybe we can give much more interesting name, or generate record, and then we're gonna receive here entity ID, right? Then we're gonna receive entity data, and index storage writer. Do we have something like dimensions or something like that, as they want to pass around there? Probably not. Probably dimensions should be like part of the indexer itself. Yeah, let me think about it. So we have record generation. Yeah. Let me think. So we have entity data. We want to generate the data for store, and we want to generate, let's say, data for entity IDs. Maybe we should provide it something like entity scope or something like that, or index scope. And we'll probably create it as maybe an actual class itself. Let me think about it. So okay, so we have entity data as a model, so it's fine to have it like this. However, maybe we can just extract some of the values. Like, do we want to expose this add and reset? Not really. We probably want to extract it into an interface. Yeah, we definitely want to extract it. So let's extract an interface here, and we're gonna extract an interface for get value, get store value. Maybe we'll add more methods later. And interface is gonna be in API. We're gonna call it something like yeah, like index record data. Probably it's better to call it like that, not entity data, but to be in the same kind of, yeah, just to be in the same style of operation. Okay, good. Okay, get store value, get value. I see already how I might want to change it a little bit. Right, so yesterday, like, we named this method get store value. You know what I want to do? I want to rename it actually. Let's actually run tests just for sure that everything is passing, nothing is, you know, like, nothing is getting failure. Okay, so let's rename it from get store value to get scope value. Oh, wait a second. Why did it complain? Okay, because it complained about this one. Okay, so somehow it's taking vendor directory here. Let's put it actually to ignore, so we don't have it double times in our editor, because otherwise, like, it would screw up the code completion and the places where I did files. So let's do rerun. Yeah, why keep memory changes? Okay, this one I don't want to work with. Okay, do refactor. Did it work? Okay, get scope value got renamed. Okay, that's good. And now we also might want to have some other kind of value. Yeah, so we need to rename this one to scope ID. Oh no, not like that. Let's do scope ID. Let's run our test. Okay, what does it complain about? Nothing bad. Okay, so why I'm doing it like that? So I have a separation of write operations and read operations. Okay, so I want to remove this method as well from interface, because I don't need it in interface level. So I need only like get scope value, get value with the field. And probably I also want to have another kind of data to be stored there, right? So I'm thinking, like, do we want to put here a logic related to prices? Probably not really much, like, because I know, like, maybe we want to have something for a specific field, right? So it's interesting, what can we do there? Not really much, I think. Okay. So another thing that I want to create kind of a read-only object, and oh, it's so tough music. Just a moment. Let me change it a little bit. First of all, let's make it a little bit not that loud. Let me also change the track in Spotify as well. Yeah, this is better because another one is a little bit too much on my brain. Okay, good. Now I'm gonna create index scope. So this is kind of gonna be a just read-only data object. It's gonna be a read-only class and also final, because I don't want to let it to be extended. I just want to be like a value object. I'm gonna pass here as an argument. I want to pass here store IDs. Private array store IDs. Okay, and I want to also pass here website IDs in case if this index covers multiple websites, so we have that information as well. And then we're gonna also pass here customer group IDs. So this is kind of like scopes that we care about when we build indexation, and it's common to have stuff like that. Also probably not private but public, because class is read-only. It won't let users of those properties to change it. So we can basically create a public property, and then because it's read-only, no one will be able to modify store IDs and website IDs and customer group IDs. So then I can pass this index scope into index generator. So first of all, like here it's going to be index record data, and here's going to be index scope. Then when we receive entity ID, we can ask index record data for all of the scopes to retrieve particular information, right? So we can generate now a record for each of the type of data we're gonna generate, for each of the store views, for each of the customer groups, and so on. So it should be much more easier to work with such index structures then. Okay, now let's put some comment here to notify that this is going to be this is yeah, index generation scope. This one is actually also going to be passed into loaders. So let's also create a loader as well. So we have an index generator. And now we're going to have index record loader. So this is going to be an interface that's going to provide for us data. So public function. So we have like stuff like that, get scope value, and we're gonna have also let me see what's about our entity data. It has also like add method and add store value. So this one we actually can rename add scope value. So probably we need to rename this one into add value to be consistent. Okay. The value is renamed. Let's see if we run a test. Everything still passes. Good. So we have add value. And we have add scope value. I think we need to change it a little bit because we already have like override values, but now I realize like sometimes we might want to create a separate data structure for another kind of values. But maybe we just need to extend here. Because let's say if we have like just a value for data, but we might also want to modify just single field here. So that's why we probably have to rename this one not into add value, but into set value. So this one is sets stuff. And then we're gonna have another method, which basically gonna add more items. So now we're gonna specify also extends main entity. So we create like these items, and then we do entity data add value. Apply that for value 1. We're gonna specify name to be name 1, and then we're gonna do a test and verify that this assert equals of this entity data get value of first entity for a field name to be equal to name 1. Here it is. This one should work. Okay, because method doesn't exist. So let's add the add value function. And here we're gonna specify string data and mixed, well, string field and mixed value. So right away field that is gonna be equal to value. Okay, should be good. Not really. array given. Okay, interesting. Yeah, because I didn't specify it correctly. Okay. Another thing that I want to modify there is that when we specify here an array for add value, it actually extends the value, not overrides it. So merges array data on value addition. So let's say we're gonna have main data, so we are gonna set the value, and let's say here we're gonna have tier price table, for instance, and we're gonna specify an empty array, but then we're gonna add to tier price, we're gonna add a value of let's say first website, yeah, this is a little bit complicated, I think. Probably we have to add a little bit more involved method for that, because I'm thinking about data like customer group, right, and website ID to be specified there. Probably, yeah, for tier prices, we probably need to do a little bit more involved data structure. So if we talk about the tier price, what kind of dependency we have? We have values from customer groups, we have values from websites. Let's actually take a look at tier price table structure. I probably think too much about it at the moment, because probably I'm gonna spend more time when I'm gonna write price indexer. Yeah, let's go to catalog, tier price table. Oh yeah, let's start an environment. Warden envelop. Wait, this is not the right table. Oh, it's gallery. Okay, gallery is not interesting for me. What's interesting for me is a tier price. Okay. So we have all groups. Customer group ID. And then quantities and so on. Okay. So what we can do, we can already, like when we load the data, we can do some kind of generation there. But let's see. So we have customer group ID, we have website ID, percentage value, or value. I think percentage value was deprecated a long time ago. Into your prices, let's go into the admin panel just to double verify. App. Just a moment. So I need to go with mail hoch more than. Okay. Good riddance. So this is Magenta admin, for which I need to scan a QR code just to log in. Okay, let's see. So as it's just a test environment, you anyway cannot log into it. So let's go with check on the prices. Let's see, can you actually add from tier prices? Where's advanced pricing? Yeah, here it is. Yeah, I think it was deprecated. Oh no, it's not deprecated. Okay, so you can specify still a discount. Okay, good. So we need to take it into account when we're gonna generate the information. Okay, so all groups, all websites. Wait, you cannot specify it for different websites? Wait, I have multiple websites, right? Because here in stores, websites, I have multiple websites. Why I cannot do that? Is it because I have like global price configuration? Not global price configuration, but local? Sorry, I don't have it enabled. Let's go and enable it actually, just to have the data properly set up here. Catalog, let's go into storefront, into price, and the price is going to be on website level. Good. And now probably I'm going to have a huge problem with price reindexation, right? It's going to be fun. So let's see if I'm still gonna see a price on the front end and products. Okay, still there, so I don't need to run a reindex because the reindex for price on this dataset takes a couple of days to finish. So yeah. Okay, that one is done. Let's go on and continue with the code base changes. So we're probably just gonna add a value that by some arbitrary information. So if it's all groups, all websites, is gonna be a default. Okay, I see what I can do there. Okay, so we can add a value, and then we can add another method, actually not an add value, but extends array value. So we're gonna have another method to call, I'd say extend value, which is gonna use another thing called key. And for that extended value, what we're gonna do there? Let me think. So for the extended value, it's gonna have, yeah, also mixed, because I don't know anything else. Okay, so let's not implement it yet, and let's just use it in a test case. So what I want to do actually is just to have some kind of lookup array over there. So we'll see how it goes. So we have current batch by table. Okay, that's good. Then we have that kind of information. Let me think about it. Yeah, it's interesting. So we have oh yeah, I'm staring at the wrong stuff. I wanted actually to go here. So we have an extend value, and let's go to test case. Let's see. So what I want to do, I want to extend, yeah, as the test is gonna be extends array value. And off entity. We're gonna use something like tier price. Then we're gonna say, okay, we're gonna extend value of tier price. With a key all websites to be something like yeah, it doesn't matter what I'm gonna use there. Let's say 1. Okay, and then we're gonna have there as well. We're gonna have there also tier price, right? So let me think. So we're gonna have a tier price, and we're gonna have also all groups. Also some kind of a value. And then there's gonna be a website. Let's say 1. Or yeah, something like that. Should be okay. Done 2. So it's 1, 2, and 3. And let's make sure that the value of tier price is then should be merged array. All websites 1, all groups 2, and website 1, website equals 3. Okay. Let's see. Let's run a test. doesn't sound like it ran a test. Oh yeah, I didn't add the most important part, to mark this function as a test. Fails transitories are equal, yeah, because I didn't implement this extend value. So what we're gonna do, we're gonna take this entity ID, field, key, and we're gonna set a value. That's simple, I think. Why after test is not working? Interesting. Okay. That one is green now. So now we can extract an interface. So let's extract another one. Let's go to refactor and extract an interface for add value, set value. The getters we don't need. Also, do we want to have reset method here? I don't think so. Iterator as well, not really needed. Okay. We will call it index record data. Let's call it mutable data. Okay, and it's gonna be living in our API. Yes, please add it to. So we have mutable data and we have regular data. And here we're gonna have index record data loader, I think. Yeah. Probably I should rename it a little bit, maybe because I want to have it in the same order. Or let's keep it like that. Yeah, it's not a big deal. Also, it's gonna extend index record data. So basically it means as soon as you implement mutable, you don't need to implement index record data interface. Okay, good. This one gonna be fine. The tests are still passing. What else I wanted to do? I wanted to implement the loader. So index data loader. What do I want to do here? I want to load data into the record, into the mutable record. So let's see, public function load, and it's gonna receive let's see what kind of stuff it's gonna receive. It's gonna receive probably it's gonna have two methods. One is gonna be load by range, and another one is going to be load by IDs. So let's do it this way: load by range, and it's going to receive index scope. And then it's gonna also have index. Yeah, so the range is gonna be int min entity ID, int max entity ID. Okay, good. What else? Also, we'll need the mutable record index, record mutable data. So this is where we're gonna load stuff. Okay, let's close this one up. Do we still fit into the line now? Okay. Let's keep it then on separate lines. And another one is going to be load by IDs. And it's going to be an array of entity IDs. So that's basically how we are gonna implement our EAV data loaders. So very similar stuff that we did in a reference implementation. If you still remember from yesterday, in indexer there is in index resource there is those load products by condition, and it kind of receives this array of conditions, and then it populates those arrays. So this is basically loaders are going to be implementing this part. So here we can see that it just assembles an array together. However, in our case, the array will be assembled by this index record mutable data. Hey, Suderk, thanks for following. Piotr and Process 8, also thanks for following. So let's see. We're probably gonna implement some simple test, right? So the index scope is basically some kind of, actually we can have a reference implementation of this index record data loader that takes multiple loaders and walks them over and over by loading multiple. So let's see, let's make it here for this entity data. Let's make it a concrete class name that is different from what we have right now. We'll put it array index record data. So it's more tells about the implementation details here. Yeah, let's also rename it from store data to scope data. Okay, good. Oh, we actually could change it a little bit. We could actually do it without extend value by just having different field names. But okay, not a problem. Yeah, not a big deal. So what do we do next? So we have this thing. Okay, so I wanted to create a reference implementation for one of the classes, but first, yeah, let's rename also this one as well into array index record data test. That should be it. Now we're gonna do another thing here. We're gonna create a new model, and for that one first we're gonna create a test, and we're gonna call it composite index record data loader test. Extends. Oh no, not monologue test case. Let's see, test case here. Okay, good. Now we're gonna create here an actual implementation. Composite index record data loader test. And what can we do again? We can implement the data loader interface, not this one, not this data loader, index data index record loader. So we're gonna implement this just, you know, like to indicate how many times something was loaded. So we're gonna say data set value, let's say what's we're gonna set as a value. Let's say we're gonna have some kind of index. So private times called, and here, yeah, it's gonna be integer. And what we're gonna do there, we're gonna specify this times called and we're gonna increment it after we assign a value. And here we're gonna say load by range. Oh, okay. Here's what I'm gonna do. Here I'm gonna specify the as entity ID is this. And we start with, yeah, well, let's probably prefix it so we have actually a non-zero integer. And here we're gonna specify load by IDs, load by IDs. And why I'm doing it like that, because I don't want to create a separate mock, and I don't want to use a mock library in order to test stuff. So I prefer like just verify a state afterwards. This is it, and now I'm gonna create composite index record loader. Oh, I name it test. Okay, that's wrong name. Record loader. Okay, good. So, is it clear the direction we are going, dear viewers? Let me know in the chat if you have any questions about what we are doing right now. So is everything clear or not really? Just to double check if you still hear me. Okay, looks like the sound is still going on and quite well. Okay, probably you all are busy with other stuff. We have 11 viewers at the moment. Oh, high process 8. Okay, good. So the process 8, so where we are at? So right now I'm trying to create this index record data and data loader itself. So the data, it's containers that we created yesterday. We called it yesterday entity data. In order like to populate data from the database into PHP array structure, and then from that array structure we can actually generate batch records that's gonna be written into the indexer. And what I'm doing right now, I'm gonna create a composite variant of this index record data loader that will invoke other data loaders in specific order. So hope that clarifies stuff. So now what we're gonna do, we're gonna go through record loader, and we're gonna actually instantiate it, yeah, first. New composite record loader, and we're gonna instantiate it with an array, right? So we're gonna instantiate a couple of times this to be provided as an array of loaders, and I expect it's gonna be like 3 times. And here I'm gonna specify public function construct read only this So it's going to be loaders, and it's going to be an array. So this is it. And that array of loaders is going to be something that implements that interface. So let's specify it here. We also want to do some kind of verification, but we trust the developers that they will probably properly specify a type through the eye over there. Okay, so array of loaders, we're gonna say it's index record data loader, an array of it. So that should make it clear, and it also should implement index record data loader itself. Oh wait, I didn't do it on interface. I didn't mark that method as void, because yeah, it should be void because it doesn't return anything. Okay, done. And here we fix it as well. Okay, good. Now what we're gonna do in our test, why it's called test? That's wrong name of the class. Okay. Oh, okay. Let's make the class itself read-only. Okay, good. Do we have any other classes that can be done read-only? Can be made read-only? Not really, probably. Let's see. Probably this one can be read-only as well. Oh no, not really, because here's an array that is not read-only. Range generator, maybe. Hey, range generator can become read-only. Good. So some improvements. Insert a duplicate generator. Why not? Oh yeah, we cannot make it read-only because it doesn't have any properties. Okay, here the rest of the things are not that much different. Okay, good. So we have generator. Okay, good. Now we can implement do some tests. Here also void. So we're gonna create a test here that's gonna first of all load by range and invokes a load by range on all child loaders. Okay, and then this record loader load by range, new index scope, empty arrays, and then what else do we specify there? And then we specify the writable storage, so we create a store array and record data, new index array record data, So we're gonna pass it here, and then we're gonna specify a range 1 by 1 till 1000. And then we're gonna do so let's see, here we have a load by range being executed. Now we can verify a state, this assert equals array record data that we've passed with new array record data maybe we want to also make it possible to do it through a constructor as well. Let's try it. Public function construct, because I want to just specify the data that I expect there in a test. And yeah, it should be done. It should be fine like that. Okay, this one is here. Then we're gonna do, it should be a times called. Okay, let's switch a little bit. Now let's go to here and do some verification. So it should be called like 3 times as far as I understand, and it should have load by range in all of the items. So it should be 1 load by range true, and then it should be 2 and it should be 3. So just simple verification if something is called or not. Okay, it fails because I didn't implement it. So let's do it here, and let's do for each this loaders s loaders is loaders this loader load by range, index scope, and data, and min ID and max entity ID. So now it passes. Okay, good. I'll go to the next test. Good. Now we're gonna do the same for load by IDs. So we're gonna copy it over. And here we're gonna call load by this, and it should be 1, 3, 4, just for example, but we know it's gonna be a little bit different result in the end. Okay, so we have load by IDs. Okay. Let's do good old copy pasta and pass around those entity IDs. Okay, and here I want to add a little bit of specification for some type of items that are shown here. For instance, entity IDs are gonna be a list of integers all the time. We're gonna ensure it at the different level. Maybe we can even like force it to be an integer. Yeah, why not? Oh, but I don't want to use array unpacking, because I was thinking about something like this, int, and then like that, but it's a problem with this kind of an approach, because if I'm gonna specify it like that, then every single time I'm calling this method, it's gonna create a new array of integers, which is quite bad for performance. So we're just gonna pass around an array, and we're gonna deal with it like that. Just pass it here as a type hint on interface itself. So we're gonna specify loads data for indexer in a scope of current entity IDs and index scope and scope parameters. Into index record data with current entity IDs and scope parameters. Let's say by entity IDs, and here we specify. Oh, I think that's enough of explanation of the public method. Into index record by entity ID range, and we can remove the type hint because it's just a name of the method, and the rest of the stuff can be inferred from the type there. Only for array types we need to specify something like that. Okay, this is looking so far good. Let's run tests again. Okay, tests are passing, so nothing from documentation change affected the test scope. Let's see, do we want to add some explanation here? Probably yes. I'm gonna specify that it's an array of integers, an array of integers here as well, and here too. Okay. Here I also want to put a little bit more information. Let's say we put here index data scope, current, let's say current index data scope, used to slice index generation into multiple create multiple clusters like website ID, customer group ID, or oh yeah, or here as well, product ID, site ID, something like that. So we have like a scope of different variations of data. That's good. So I think we also need to have another method here. Because for some records, we'll need to have also preparation of the data. So this is what I realize is kind of important. So we're gonna specify, we're gonna prepare index scope. So for instance, for categories, we need to have some kind of a scope table. That's gonna be invoked there. Okay, so we're gonna also put here maybe like we have to name it a little bit differently. Yeah, let's make it void. What I'm thinking about is that, yeah, we are gonna have some data being prepared, but also we want to make sure that then it's steered down. But do we want to do it for every single data loader or only for some of them? That's the question. Probably it should be some kind of special use case of the data loader. Yeah, so probably it shouldn't be here because we don't want to make it everywhere. We're gonna have some loaders that are aware of other interfaces. So let's do that here as a separate interface. Let's create it. Index so we say it's index loader say index data so let's think a little bit about it. So we want to create like a class that's going to be invoked every single time when we do reindexation before and afterwards, so we can clean stuff up after the indexation has finished automatically by our indexation framework itself. So let's probably do that here. Yeah, so we're gonna name it index. Let me think about it. It's gonna be a index data so that is the index record loader, and this is going to be index data what do we call it here? Like, so we have like setup, we have like tear down, you know what? I'm gonna call it index index observer actually. Yeah, because we are gonna do it before and after index generation. So index generation observer. So then I can implement on specific index record data loader. I can implement an observer that will generate specific data before and after the index has been generated. Okay. So, and we name it, we make it an interface. And here we're gonna say before generation, index scope, after generation, index scope. So that's basically two events that gonna happen, for which we can implement this interface and add it to the indexation itself. So we have our batch index writer. So we have some index table structure. Yeah, it's a little bit complicated. I think I need to think over about the best strategy for that. It's kind of hard to come up with the good idea here just by doing it on stream. So I need to think over what's the best option there. Because we have like index generator, right? That's gonna generate record and gonna put it into the index storage writer. The index storage writer itself, we already implemented it yesterday with table matches. The one that's gonna execute a batch and store it somewhere in a table. That's clear. It's gonna have like index table structure being supplied to it as an argument. Let me see. Yeah, so the index table structure is going to be something like that. So we have generate, insert, and duplicate, prepared row. But we also would probably want to create a table there as well. Let me think about it. So we have the storage map. So it finds the storage name based on row values. We're probably gonna also have index storage factory as well, right? So the factory is gonna create for us yeah, so here, for instance, I see that it receives the table structure. This one can just be somewhere abstracted away. Okay, so this is just an interface that can have a concrete implementation within it can have like an implementation itself within the database itself. Okay, so we'll need to have a factory for this one, for storage writer. And index storage writer is going to be used in generator, so we're going to pass it here. Let me think about it more. So we are passing here the stuff like that. So what's table structure? Here is gonna be an interesting one. Probably, yeah, we can just think about it in very simple terms. Yeah, there's nothing too complicated there. This one can become also through DI, but this one is need to be parameterized. Okay, I see how I can do it. Good. I see already an idea what to do there. So for this one, we're just gonna create a very simple factory. So table batch index storage butter factory. And it's gonna have a method create writer. I'll just create with what kind of stuff that is important for me to parameterize and what is not the implementation details. So index storage map. So index storage map. So that's gonna be a storage map being an argument. Then we're gonna have also table index table structure. And what else we're gonna have there? And probably the batch size, right? Yeah, and the batch size. So we can create now factory itself, construct. So we're gonna use an interface of object manager. This is actually the only place where you'd want to use an object manager is when you are creating factories that instantiate other objects. Sorry, here it should be private read only. Okay. Okay. Here, then we're gonna do this. Yeah, so we're gonna return back here table batch index storage writer. I'm gonna use this object manager, create table index storage writer class with some of the parameters specified. And what kind of parameters we have there? So index, okay, so it's named index storage map. Let's do the same here. Index storage map. Oh, what? Oh, I just clicked enter too fast. Okay. Then we can specify index storage map. And we can specify index table structure and the batch size here. So okay, this is the only place where we gonna use our object manager is when we're gonna use a factory pattern to create multiple storage writers for specific indexers. So this is gonna be fine. Okay, now we're gonna add here as well another interface, and we're gonna call it index storage writer factory. Okay, and we're gonna make it an interface. And this one is gonna be public function. One is create full reindex with an index scope being specified as an argument, and it should return us back index storage writer itself. And then we're gonna create partial reindex. So in both cases, it's gonna return us the same kind of interface for indexer writer, but we have like two different styles. So one is gonna be aliasing tables, and another one is gonna be just keeping stuff the same. So let me think about it as well. So we have the batch size being provided here. Okay, good. And we have storage map and index table structure itself. Oh, I hear a doorbell at my house. I need to go and check stuff out. Okay, let's make a short break. Just a moment. No, break, and let's put here a different time. At, let's say, 12:15. So I did stuff somewhere here in table batch index storage writer factory. Complicated name. Yeah, don't like it much, but yeah, well, what can you do? So we have index storage writer factory that's gonna be used for full and partial reindex. And then we're gonna have also index storage right. Yeah, we can remove actually all of that things, and we're just gonna properly create a documentation here. We're gonna specify that this one invokes all reindex writer, and this one invokes partial reindex writer. Okay, good. So the partial reindex would probably just have the storage writer, because it doesn't need to do much of implementation details. So then it's gonna be the index storage map itself. Okay, yeah, I see it. It's kind of not bad. So it receives a storage map. Okay. Let's see if I can also do some stuff here with creating. Okay, so I have a bunch of notifications coming over. Let me mute Slack. Hey, let's see. Can I mute it from the application? Align. Okay, applications. Not really. Okay. Let's make it then smaller. And let's see if we can do something more. So here I wanted to create some kind of an abstraction for storage writer that's gonna prepare for us the real writer itself plus underlying storage writer. When is it? Okay. Let me think about it. So the table structure can be just specified like it is. This one creates, yeah, not invokes, creates full. And probably without this one, creates. Might create temporary tables, or might create real index tables, and upon completion we'll switch live table with, yeah, let's say should create real index storage for each scope, dimension, on completion should switch real index storage with in U1. Here creates partial reindex writer should reuse live index storage for each scope dimension. Okay, that should be simple. So those are two different kind of storage writers. Good. So this seems like a good isolation level. I probably can even create an indexer itself. So probably index storage map is not good name as I look at it. So now that storage map is supplied here, and it looks for me like table structure and storage map are kind of live very close, but yeah, it's not needed to. Yeah, the table structure is probably better to be separated here. So I want to do some test on this one. So probably I want to like extract this one. So we'll use this for, yeah, we'll create a new interface. So we're gonna extract from this one because I want to test my indexer implementation, and for that one I actually need to have this generator as a separate instance. Oh, not correct. Yes, undo, and here we're gonna refactor, extract interface, create ranges. But here we're gonna say that it's gonna be index range generator, but here we're gonna say that it's gonna be part of API, yeah, or SPI. Probably it's part of SPI itself, so yeah, I think we can move it into the model. Event resource model. Okay. But what I want to change, actually, I want to change it to be a little bit different. Because the table range is gonna receive as an argument a table name, so that should be good. Yeah, that should work. Because I just need to specify a batch size here. And the batch size for ranges is a different batch size than for something else. Yeah. How about storage writer? Not much things there, yeah. So we don't want to pass around a lot of stuff. So only like table batch insert is the one that's gonna use the batch size for table inserts itself, and there's another the batch size is gonna be used for entities itself. So those are two different things. Let me think. Okay, so we have this one. I'm gonna rename it to range generator. Skip, okay. Yeah, skip, because I want to actually rename this one into table range generator. Implements this one, and these two things are actually gonna be here as private. And it's gonna be this entity ID field, and here it's gonna be this entity table. Okay, that's more than enough, I think. And probably I'm gonna rename it into table name, and here I'm gonna rename it into primary key. And here as well I'm gonna rename it into primary. Okay, good. And it's more generic and more applicable to every single table. Okay. This should be perfectly isolatable, right? Hey, Adam Vaklavchik, thanks for following. Let's think a little bit about this code. So I'm gonna use, probably I can also rename it into ranges. Okay, wasn't enough. But for system changes. So what we're gonna do here now, so the range generator is gonna return us ranges, then it's gonna be passed into the record data loader, right? And a lot of stuff is gonna be then passed to generate index generator. With an entity ID returned from the index record data. Okay, so now I have an idea how it's gonna be implemented. Let me think if I can make it a little bit better or not. So the storage writer factory is gonna like create stuff like that. Yeah, so basically now I can create an indexer itself. So we're gonna create an indexer class. So this is something that's gonna be used for each of the indexers, right? So let's see. It's gonna be an indexer. I think that's basically it. Yeah. It's gonna implement MVO action. And it's gonna implement indexer action. So we're gonna name it as mview action, and we're gonna implement it as this one, indexer as an indexer action interface. So we're gonna have all of those methods, right? So to prepare it, we need to have we need to create those index scopes, all right? So we need to have something like index scope provider. And it's gonna be an interface as well. And it's gonna be an iterable. And the iterable is gonna be over scope, index scope. So returns list of scope slices for an indexer. Okay. So this is something that I will need to provide for an indexer. So let's think about the constructor here. One thing right away, we're gonna make it read-only because it's not gonna modify constructor arguments. Let's see if Magenta actually allows me to use read-only classes here. I hope it does. Private index scope provider. This is one thing that we're gonna need. Another one is we're gonna need index storage writer factory. We will need index data record data loader. Okay, good. Okay, this is good. Then we have the record data. We already have it. We have storage map and storage map probably is not something that we really need. Okay, so that's all implementation details. Let's see. We are right away gonna mark this class actually as API because this one is not gonna change. It's just generator of a SQL statement and we're gonna use it all over the place. Yeah, so let's have some explanation here. Okay. Yeah, it's a little bit weird. Oh. Yeah, let's at least create indexer and then we think about other solutions. Okay, so indexer, so it's gonna have this one. Also, what it we'll need to have as well a private index generation observer, and it's also gonna have an index generator. Okay, this looks like all set of the dependency that we're gonna use. Kind of a lot of dependencies, but not too much. Yeah, let me think about it. Yeah, everything looks good. I think we cannot collapse anything here. Okay, let's go and create a test for that. Sorry, it should be protected function setup. Set up. Okay. It's gonna be an indexer. So indexer. Oh yeah, we're gonna do a lot of tests. New indexer. Okay, so what do we have first? The index scope provider. So we need to implement that one. Implement index scope provider. So we're just gonna return some scopes. Index scope. Let's say 1, 2, and 3. Website 1. Then let's say customer groups 1, 2, 3, and 4. Okay, good. Let's put here 2, and here we put 4, 5, and 6, and here we're gonna specify 5, 6, and 7. Yeah, 2 scopes is more than enough for a test. Good, so we can specify this as a scope provider. Okay, so this one is gonna actually be moved 1 record up. So we're gonna move it. Oh, no, not like that. We're gonna move it to a model. So here how it will look like. Okay, that's good. Okay, so we have record data loader, scope provider, generation observer, the generator itself. I feel like I just want to extract this part away. I just used the scope provider. Yeah, these 2 things are definitely like needs to live outside. So I can pass the storage writer. Now I don't want to make it too complicated to set up, so that's why I basically put it here. Where is the index generation observer? Yeah. Yeah, definitely I want to create like a separate indexer model for that. That will take care of that stuff, and this one is gonna only take care about this 2 things. So we'll create another interface called indexer action. Index action. So we can extract this port. So we can provide a scope, we can provide the record data, yeah, so we can provide the IDs and the writer. Okay, that should work. Good, yeah. So index action, and it's gonna have two methods. Re-index full, index scope, index storage writer, so I think it's basically the only two things that's gonna do the indexation. That indexation depends on. Let's see. I have record data loader. It can be encapsulated within the indexer itself. So then I need only scope provider and storage writer factory, and then it's gonna execute those actions then. And here we're gonna do reindex by IDs or index partial. Here we're gonna specify or maybe we do reindex range. Probably we can abstract away the range generator itself here. So here we're gonna specify int start, yeah, min ID and max ID. Here we're gonna have IDs. Yeah, let's name it entity ID, max entity ID. Here we're gonna specify entity IDs. Oh no, no. No parameters. Reindex full. I remembered why I wanted to extract it. Okay. That should work. We don't need to have those type annotations. We need to have annotations for entity IDs. Okay, then it's good. And here we're gonna specify that, yeah, first of all of them are void, so they're not returning any data. Here it's gonna do reindex full index storage. For provided index scope. Yeah, looks good. So instead of all of this stuff, probably the generation observer might still be there, but generator definitely not. The record data loader is not gonna be there. We only like have these dependencies. And another option is gonna be here, an integer field. We're gonna call it live index max live index batch. So we're gonna also make sure that when we have like entity IDs being provided to one of those execute lists, row, and IDs, that we're gonna also make sure that the maximum number of items in the list is gonna be sliced. Oh, it's actually gonna be an array. Oh, it's gonna be an integer and with no default value, or maybe with some default value. Let's see. Live index batch size. Let's call it like this. And let's make a constant here. Const public constant. Default live index batch size, and we're gonna specify it something like 1000 self default live index batch size. Should be good. And it should have an index action being provided as the index actions is going to be executing those operations. So we have generation observer that's going to be executed before each of the scopes. The scope provider will generate for us a list of scopes so that we have to walk over. Then we have the storage writer factory that's going to create for us tables and insert data into it, and on finalization of the index it's gonna mark them as live. Okay, then it should be whatever everything that we need. Let me look at it a little bit more. Yeah, looks like it. Hey, barbecue, thanks for follow. Let's see. So we're gonna test all these methods. We're gonna implement the action probably on our test case. So scope provider, yes. Now we're also gonna implement index action as well. And here we're gonna create a variable just to track an array of actions performed. So each our reindex full is gonna be adding to the action. So we're gonna add a new action like full scope. Yeah, let's make our scope a little bit easier to manage. We don't care much about stuff. So it's gonna be 1 and 2, so it's gonna be much more easier for us to work with it. Oh yeah, the rest should be just an empty. Okay, good. Now it's clear. Okay, now we have scope being supplied, and here I think we don't need to write anything else. And with reindex partial, we're gonna add a new action like partial scope, and here we're gonna specify entity IDs that were passed as an argument. Then what? So this one is an action. Okay, observer as well. So here we're gonna say events. Events scope. Yeah, index scope. I can probably rename it a little bit in interface, because I think we can just name it scope itself. Here too. So as you see, I just like use the self-implement on a test of the interface in order just to capture the behavior instead of creating a mock. Then I'm gonna do this again. So because this implements a generation observer, this also implements an index action, right? And it will also have a storage factor implementation as well. Okay. More interfaces to implement. Storage factory. Yeah, but why it doesn't complain? It should. Oh yeah, two abstract methods are missing. But why PHP Storm doesn't complain about it? This is an interesting question. Okay. Let's implement them. Finally. Now it tells it, yeah, we need to implement this one. So we'll use this. Oh yeah, it's different this. So I forgot how to pass around stuff here. Oh yeah. Oh, now I remember. No, I don't want to do stuff like that. So this one is going to be like empty. But on finish, I want to make sure that I specify that so can I do something like that? No? Okay, so I have to specify it like this. So it provides an action, and here oh yeah, because it's read-only. Okay. Let me think. So we have a reference to actions, and what we pass here this actions. Okay, so it should be able to add items over there. Do I call finish from here, or it should be a responsibility of the index action? Probably, yeah, it should just be responsibility of index action. Yeah, then I don't care at all about whatever I specify here. It's just basically a stub. Basically, it's gonna be the same. And then I can specify that the fourth dependency is also gonna be this. And the batch size, let's say we're gonna have like 3. So it's much more easier for us to test. So we're gonna test that executes action on full reindex. So this indexer execute full, and then we're gonna verify a state. Assert equals that this actions equal to what do we have? For every scope. Okay, good. And here we're gonna specify that full, and the scope is gonna be new index. What was it? It was something like that. And then was something like that with the number 2 in it. Okay. Hey, Process 8, what are you asking about? I didn't see your message. So, let's see. We have this one. Okay, the test fails. Then that music is too much fun, I would say. Let's make a little bit more nicer music. I was about why didn't flag the missing apps. Oh yeah, yeah. I don't know why. It seems like I was in the right directory, like I was in modules indexer, but yeah, it's just didn't work well. So let's implement then the indexer itself. So here we're gonna specify scopes. This scope provider get scopes for each scope as scope. You know what? I can just inline it. Control Shift N, or what was the? Yeah, like that. Now I'm gonna do scope. Okay, so those are all of this stuff. Then we do this index action, execute full, reindex full with the scope, and we need to use this index storage writer factory, create full, with index with the scope itself. Okay. So those classes are not gonna be there. Okay, the test passed. So now we're gonna go and probably implement another one. So this so far is actually very simple. Now we need to add another test. Test for that it executes an observer after indexation is done. So executes index observer after each full indexation on scope. So we again gonna do execute full, but this time we're gonna do this third equals. First state, yeah, for me it was a little bit music that was before. I can turn it back on, but in my opinion, like, it was too quiet. I was almost like feeling like I'm gonna fall asleep soon because of the music like that. Oh, it's wrong one. I think we need to go. Yeah, this one I think was it right? Yeah, it was the previous one. It's so quiet. It reminds me like of the old computer games like Mojang or something like that, where you have like that music on the background, but it also a little bit too quiet. Almost like feels like I wanna go and fall asleep under that music. Okay, so where I was like on execute full, and I wanted to add an observer. So we're gonna verify events this time. So here we're gonna do that events with new scope, index scope 1. And 2. So it was index generation observer. Now I'm gonna do a verification against this events. Okay, let's see. The test should fail. Yeah, so scopes are not there. So let's implement them. And we're gonna be this observer before generation scope. Okay. Oh yeah, I think that's exactly the problem, because events need just to add a scope. And you know what? It should be after. Yeah, so I completely messed up here. So I need to change my test now. So it should be a before event. And after event. The same thing should happen for scope number 2. Let's do that. So, you know what's a good thing today? Today, during the stream, the camera never froze. And this is kind of good news. Okay, so 1, 2. Good. The test is not passing. Yeah, because the implementation is not yet matching. Oh no. What's up with that one? Okay, so this is that one. But I'm looking actually here. I didn't want to go here. Right, so again. I just want to work with items over here. Okay. And now we're gonna implement the full implementation here. We're gonna do this indexer, generation of server. After generation of scope, well, you're gonna be passed around there. Okay, good. Now the test is green. So load by this, load. Okay, we need to do another test case now by multiple IDs. For that one, I'm basically gonna copy paste some stuff. And I'm gonna just rename the methods because I wanna save some time here. So we have, the next one is execute list. Oh, but for the list I think the tests are gonna be a little bit different. Okay, let's do different stuff. Let's do for execute by single item. Executes action on single ID update. So execute with row, if we say 1, and we expect that it's gonna be partial or a couple of items partial, and we're gonna specify that it's gonna provide us 1 as an argument. Okay, it fails because we don't call anything there. So let's do that. And then here's this index action. Reindex partial. Scope. What else do we specify there? We also specify there writer. Create partial for scope. Right. Then we have another one, and we have list of entity IDs, and for that one we're just gonna specify an ID here. Okay, that one seems like correct. We ignore for now the batch size. Okay, good. Now we're gonna create another one. This is the wrong test. We are interested. Yeah, does it work with this one? Okay, it works like that. Okay, so I can do Ctrl-Shift-T in order to jump to the test, but it doesn't jump to the right method, unfortunately. Yeah, it's time to try to use NeoVim at some point to be able to quickly switch between files and editor. So the tests are passing. Let's move this stuff a little bit here. Executes partial. And we're gonna do the same. Executes observer. Generation server on action update. On single action update, on single action update. And here we're gonna specify before and after. And here's gonna be one. And here we're gonna check events. And we're gonna do it 2 times because there's 2 scopes. Okay, the test fails, right? So we need to implement the implementation now. So, right, we don't have any data there. So let's go back here. And I just add this generation observer before generation scope. And this Linux generation observer after generation scope. Good. Test pass. Great. Now I would probably do it for execute by IDs. So let's see. Here we have this single ID, and here we're gonna specify multiple and here we're gonna specify method called execute with the list of IDs 1, 2. And we expect that both of them are specified there and the observer is executed too. Just for the sake of difference, just let's add 3, 4 there. Okay, good. See, yeah, it doesn't get implemented for execute. And I can just copy paste this stuff and just replace ID with IDs. Nice. So there's problems that I made a typo there while copy pasting code. Okay, good. But now I see that those 2 pieces of code are basically the same. So what can I do there? I can extract that method. I'll call it reindex by IDs. And this one as well. You see, it was smart enough to replace both places in ID with a refactored code. Okay, good. Now we have this execute list to be passed around. It probably will break interface. Oh no, not really. Okay, here it doesn't break anything. Okay, good. So that one should be okay. Yeah, and now the last method is left is execute list. But that one is very simple because we just can copy paste the test and just replace the method we are invoking. Yeah, let's clean up the code here a little bit. Looks good. Executes partial action on execute list. So let's do 3, 4. And the same is going to be on execute list. So okay, our 2 tests should fail now, right? Both of them failing? Okay, good. So we just copy paste this one. Okay, nice. Now our test pass. However, now I want to add a couple of interesting test cases, because I want to make sure, for instance, that we are typecasting values to integers. And I would say fixes input data on partial update. So we say execute with, let's say, 1 and 4, and here we're gonna say 1, 2 for list, and here we're gonna specify it for row. So in case Magenta like gives us very bad data, we want to make sure that the data gets fixed. So we want to make sure that this one gets transformed. Okay, that's good. Then 1 and 2, 1 and 2, 1 and 2. And then we're gonna also do it for 1. Let's do same. How will it fail? Okay, probably I can do with equals. I can do something different. Let me see. Let's do something like that. It still passes. Okay, the PHP type system is very interesting. Okay, how do I test it properly then? I cannot use array same because of the index scope. Right. Assert equals, okay. And what is canonicalizing? It's interesting. Okay, so if values are the same, let's try it. Maybe. No, the same issue. Assert same, maybe. Maybe it's not that bad. Assert that. Is it identical? Identical might not be the same. Yes, array. Okay, so it's mostly about different kind of data. Yeah, let's add some kind of data like that, maybe. No, still. You see how crazy PHP is with data comparison. Okay, let's do something different. Let's do private const. Oh yeah, I cannot use something like that in PHP, unfortunately. What can I do here? Okay, private. Maybe I can just use something like private array scopes. And this is just gonna be yeah, because I wanted to compare complete equality. So the first scope is gonna be new scope, index scope. And scope number 2 is gonna be 2. And then when we are returning back scopes, let's see where we are returning scopes. We do this scopes 1 and this scopes 2. So now I can use something like that. Scopes 1 and scopes 2. Here and here. I can actually replace it with same, because now it's the same object. Those tests are still passing, good. Okay, good. Let's replace this one as well. Perfect. And also third same. Third same. Okay, tests are still passing. I could have just do something like this. Replace all and one with one. Okay, here it's fine. So now we can do this one also same. Okay, now finally we have a failure. Perfect. Now I can actually go and fix that pain. So we can say that IDs equal array map. IDs. Oh, actually, we can just do something like that. Okay, should be good. Another one that we're gonna do there is removes from list. And here, yeah, we're just gonna see 3 and 4, but there's a failure, right? Because the duplicates are actually not removed. So let's add that as well. Okay, what's the problem? Oh yeah. What we can do there is something like add one, and also what do we want to do? We want to forget about this keys itself. So let's do that. Array values. Yeah, I don't like this one, but yeah, it's very small set of data that's gonna be taken care of here. Okay, good. So we have unique values that are taken inside of the indexer. Let's say indexer test. Now we're gonna add another one. Oh, let's see. The test itself. Let's copy it over. Let's now also add another test. Splits indexation. By IDs. By maximum batch size. Okay, something like that. And I'm gonna say 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's say 10. And what I want to see is actually to have 1, 2, 3. Then 4, 5, and 6. And then 7, 8, 9. And then 10. And the same I want to have for number 2 as well. For the second scope. So if let's say number of IDs is too large, we just splice by those numbers. Not splice, but chunk. Okay, the test is failing. Okay, so we have that one. What we're gonna do? We're gonna do for each. Probably even more interesting. We're gonna have something like array chunk. And we're gonna chunk by this live index batch size. Now basically everything should fail, right? Yeah, because now everything is an array, within an array. Now we're gonna do for each of these ID chunks, SIDs. Now it should pass. Yeah, okay, so now all the tests are passing and our indexer is actually implemented. Okay, that's good progress for today already. We did some good stuff related to the new interfaces we've created. The first indexer implementation itself. So this one is gonna work as soon as we provide like proper dependencies. So we didn't create yet the scope provider. So the scope provider is probably gonna be part. Yeah, this is the scope provider itself. Yeah, interesting. Yeah, let me think about it. Probably I want to create another one. I want to create a factory here. I want to create index scope factory because I don't want to rely on Magento factories to create scopes for me. And you might be surprised why I put classes into API folder, but because I don't think that this class implementation is ever gonna change, I'm just gonna do something like that. So I'm gonna create a new scope with array of website IDs with you know what, why I care about index scope factory itself. Yeah, it's already gonna be over there. So what I can do, I can just make a static function here. Create. So store IDs array. And it's gonna be static self, and what we can do, we can actually make it private constructor, so no one is gonna use that constructor like that. Everyone is gonna use it through the static method. And customer group IDs. The thing is, not all the time I'm gonna have this information for indexer, so I'm gonna specify these things as like optional arguments. So let me do a small code cleanup. No, I don't want to have this one. I don't want to do cleanup. I want to do code reformat. Actually, I can do it here. I think so. No. Okay, code. Reformat code. Okay, good. Okay, it's formatted put properly according to the rules defined in editor. So new self. I want to have store IDs being mapped into interval, so you don't have to worry when you pass it around that you convert it properly. Website ID is the same for customer groups. Now my tests are failing because, yeah, because I create an empty scope itself. Okay, so now I can make it a little bit better. The same here. Okay, now all tests are green again. So yeah, I'm using the factory method here because I don't want to use object manager for instantiating just simple data object. So it's completely fine because no one should override this, and it's gonna be a final class. So yeah, that's how it's gonna work. And now also we're gonna have here grades from provided values. typecasts, non-integer values. Okay, the tests are green now. Let's do some commit messages. Oh yeah, let's go to modules. Oh, not in the right directory. Let's see, what did I add here? Okay, bunch of stuff. Okay, let's do commit. Add scaffolding for indexer data generation. Yeah. Added new index frame components. So added narrator API, added loader API, for loading data from tables or other storages. A generator API for producing index rows based on loader data. Okay, then we have index scope, abstraction, index scope DTO. Then we're gonna have other stuff here as well. Moved oh yeah, extracted or added right storage. Right storage factory API, added mutable data API, mutable data record API. Also, we did extracted data record read API. And then we also did have some stuff related to indexer itself. Oh yeah, so we also extracted range generator API and storage index storage writer factory. Yeah, and created index and mview action adapter for internal index components. So that adapter can just be configured through DI in order to create your own indexer and specify it. Okay, push. Oh yeah. Okay, stuff is over there. Now I think we're gonna be done for today. Thanks everyone for joining. It was a little bit not that much productive session as yesterday, but I think we did kind of good progress. What's left to do is probably the specific implementation of the entity ranger, but I'll see maybe later on this week. Off stream I'm gonna create some stuff, and then for the next week I'm gonna do another live stream, and hopefully we can already start working on catalog product category indexer itself with those base components, helping us to make it a little bit faster and testable. So thanks everyone for joining. Thank you very much, and till the next time, next week we're gonna do that again. Yeah. As more people participate, as more web pages I'm gonna be able to give all of you. Thank you very much. Till the next week for the live stream. Bye.